Hello, and welcome back for those of you who have been away. And how many of you have attended at least 2 sessions today? Oh, not that many. Give them a warm hand. They've been doing a good job. I guess the rest of you have been working out there. OK, actually now it's time to really go digital. Digital and nuclear. And it seems to be, according to the theme, the perfect match to accelerate nuclear deployment and innovate in nuclear operations. And we're going to have a fantastic moderator for this. And she is coming up now, and she will present the speakers. So the president of Decisive, Cécile Messon-Neneuve, welcome up. I hope I did the right pronunciation now. But you do speak Swedish. A little bit. Thank you.
Thank you, Linda. Thank you. Good afternoon, everybody. Welcome to this session dedicated to a fantastic topic, which is the perfect match between digital and nuclear, nuclear for digital, digital for nuclear. So we all share a conviction in this room, is that we will need an abundant, reliable, low-carbon source of energy to power the digital sector. We have it with nuclear energy. But the question we are going to address during this session is what can digital innovations, digital industry bring to nuclear energy sector? So to talk about this topic, we have a fantastic panel, and I'm going to call them, and you are going to applaud them warmly. Please welcome Lou Martinez-Sancho, Chief Technology Officer and Executive VP R&D at Westinghouse. You are our host, Lou. Welcome, please sit down. Elliot Danner, Elliot, Global Managing Director for Google Distributed Cloud. Welcome, Elliot. Julien Debar, Director of Energy and Utilities at Databricks. Welcome, Julien. Please sit down. Jim Linder, Operations Service Manager at Constellation and PWR-OG Chairman. You will explain what it is about. And François Maillard, Group Chief Strategy Officer and Real Estate Development Arm CEO at SPIE Batignolles. Welcome. Please sit down. Please sit. Thank you. So, during this session, we are going to try and understand, as I said, how digital and nuclear work together. And we're going to start with you, Lou, to, I would say, set the stage. So, you are leading the digital transformation at Westinghouse. You have developed a vision. So please share it with us. Thank you.
Thank you all. Thank you, Cécile. This is obviously a very, very large team effort to develop these kind of visions. I would like to start saying that Westinghouse is a 140 years old company. What it means that actually we have a lot of data that actually we can use in this new era that we are. So the combination of the knowledge that we have with the data put us in a very, very nice situation to develop these new technologies. The strategy is pretty simple. The data is proprietary, is really owned by all the knowledge that we have for our needs. We develop it as well with our customers. And we have a nuclear-specific AI that is called Hive, that is the infrastructure. We have also a nuclear-specific generative AI model that we call Bertha. And very fun fact, we call it Bertha in the honor of Bertha Lomers. That was the first female mechanical engineer working in Westinghouse. So basically, you can ask Bertha that has all the legacy that is coming through the system. So we're very proud about having been able to build this. But our strategy is not closed. It's not because we call it nuclear specific. It means that we are doing everything our own. The strategy is what we call a technology brick strategy. So we have fabulous partners. Some of them, they are here with us today, like Databricks and Google Cloud, that actually help us to assemble those bricks in a way that actually we can use it with the constraints and the needs that we have in the nuclear industry. One of the first things that we have built when we started all this adventure is an ethical committee. I know you're expecting me to talk about technical stuff and what we are doing, but basically, without the ethics, the compliance, in nuclear, we cannot do anything. The second thing It is the training of the workforce to utilize these tools. There is a lot of restrictions in nuclear, so we learned that working with the regulator in different countries, explaining them what we want to do, but as well we utilize it a lot of governmental associations in nuclear and outside nuclear to help us understand where are the limits. What is very critical for us is that the engineers, the technicians, the business people, they are the ones that make the decision. The digitalization is there to enhance the jobs that we are doing. So I hope this set the stage for a great conversation.
Yeah, thank you. What you are describing is what we call a collaborative ecosystem. So I'm turning to you, Elliot. Can you share with us how you see the unique edge that Google Distributed Cloud can bring to this nuclear collaborative future?
Yeah, absolutely. I mean, first I want to say we're incredibly proud of the partnership with Westinghouse. And what it's really done is unlocked a whole other set of use cases for a product that we actually built for the defense and intelligence world. So Google Distributed Cloud is our fully air-gapped environment that enables folks who have critical national infrastructure requirements, who have high security requirements, who have classified requirements, to build applications that are truly standalone, but with a resource cloud approach. In other words, modern cloud architecture, modern cloud development techniques, modern cloud development skills, but in a controllable and air-gapped way. And so when we first had the conversation with Westinghouse, one of the things that came to mind immediately was how can you use AI? How can you leverage modern cloud tools, but do it in a way that maintains regulatory compliance and in a way that kind of is modular and easy to handle so that it doesn't get out of control? And we've seen a lot of that kind of experimentation become problems. You know, the Westinghouse partnership, in my mind, bringing Hive and sort of the production of the AP1000, I think really what we've shown is the ability to do modern development, modern tools in an industry that is seeking modernization. And so, as I said, we're incredibly proud of the partnership. I think it highlights how you can use safely modern tools and technology in an industry that has all of the requirements, but also that high regulatory burden.
Thank you, Elliot. So one of the first words that Lou said was data. So Julien, as a Databricks, with Databricks experience and your own experience in the energy sector, so please tell us what is your role in this ecosystem?
Yeah, thank you, Cecile, and thank you, Lou, for inviting us. Like Bertha, I'm actually a mechanical engineer, because Bertha was the first US woman to have a mechanical engineer degree. So for us, it's about making it real, right? I actually grew up in the oil and gas space. I was a field engineer. I was offshore on rigs. And for me, it's all about making it real. So at Databricks, I lead our energy and utility space. And our motto, like this conference, is about making it real. What does making it real means from a data standpoint? First is having access to your data. We all know that data is in many silos, is in many formats. And the idea is that no company today will give all their data to be copied in one place to have access to your data. So what we do is a zero-copy approach where we give you access to your data in a catalog that sits on top of all of where your data exists, which is your object storage of your choice, right? So data access is where we play the most, giving you access to your data, being able to know who is accessing it, what is the lineage, and auditing it. I think the second piece is really around collaboration, because the truth is our energy systems today are so complex that it's not going to be done by one single company. And even within a single company, you have many different business units. So you need to be able to share your data across. And again, the sharing the data doesn't mean copying the data, because then you lose your single source of truth. So what we developed is a protocol called Delta Sharing, where you can share access to your data to the people you want to give it to. So summary, really our place in the energy space is about giving you access to your data and empowering you to share it with the people you want with all the right governance.
Thank you, Julien. So now we have to leave the data field and to go on the bricks and mortar field with you, François, of course. So let's build on that partnership angle. So how does Peabody see its role and its construction expertise fitting in this partnership?
Well, when I look back over the 25 years I spent in infrastructure and strategy, the main role of Tribune is to transform massive CapEx program into cost-efficient, replicable project and delivered on time. That sounds very simple, but it's quite complex and a big challenge. And our role here and why we're here today is, in fact, brick and mortar is going more and more digital. We are we have a digital backbone that can help first and meet the requirements of all this highly demanding and high quality industry that it is nuclear, be it on the regulatory side, the quality side, because for obvious reason. But digital also helps to find, let's say, unique, original solutions. That's the POC we have done and what we are doing today with Westinghouse. Digital enables use additive fabrication, 3D printing, concrete 3D printing, and with this 3D printing, we are able to do something we cannot do in another manner. We can have some bricks with very complex forms that prevents all the radiation going through the wall. That sounds very simple said like this, but if you take some bricks, you have some potential leakage that are meeting a very important requirement in the industry is no risk. And on top of that, digital enables us to, and our industry, to make leapfrog, be it in off-site construction, other solution, and also making more reliable delivery CapEx plan. That is more than a big challenge today to meet the requirement of the customers of the nuclear industry.
Thank you very much, François. So, Jim, let's finish this first round of questions with you. So you have two hats around this table. First, you're in charge of the operations for Constellation, largest nuclear fleet in the US. You're restarting operations, and you have a strong commitment to deliver a huge quantity of electricity for the US economy. But you're also chairing the owners group for PWR, so it's something like 1,800 members operating less than 200 PWR around the world. So you have quite an extensive view about which role generative AI could play in operating those reactors. Please share it with us.
Thank you, Cecile. I appreciate that, and appreciate the opportunity to introduce the PWR Owners Group. As you said, representing thousands of members and over 180 reactors. So from that perspective as the chairman, I see many of the digital innovation and AI tools being in place right now. My role as an operator at Constellation in the main control room, a licensed operator for 25 years, and a nuclear engineering background, I see that there's a spectrum of AI that's really come into nuclear power. And the main control room today doesn't look like anything like the main control room of 25 years ago. And I see the spectrum of AI in which it starts out with augmented information delivery. So it's searching, being able to search, being able to get a different perspective on information from the plant information. So that transfers to analyzing that data, and then next is advising. So an AI can advise engineering and operations on the best decision making. So that coupled with, I think the last phase of AI is automatic. But I see all of those phases in the nuclear power plant, in engineering, across the industry today. And so I'll share with you a couple of examples as we go through, but I just want to say that we're using this knowledge transfer today. We're using AI to monitor our equipment today. And we're using AI to in some ways, reduce the resources necessary for work planning in current O&M and for design phases for potential construction. So the uses are there, the applications are there, and we're seeing that being effective at making O&M reductions, making us more efficient in the industry and safer.
Thank you, Jim, for this important message. It is happening right now. We are not talking about something happening in the future. So let's now go to the second round of questions. And I would like us to think about the challenges we are talking about. We know quite well the challenges of this industry, some possible delays, cost overruns. We're also in a highly regulated environment, as you reminded us, Elliot. So how can we approach them differently thanks to those technologies? So Julien, with your cross-energy lens, please share your views on this.
Thank you. Yeah. I'm not going to pretend to tell this audience the challenges in the nuclear space because they'll know much better than me the challenge around the permitting, building, operating, maintaining, but the truth is that it's the same in all the other industries that we cover, right? So like I said, my background is more oil and gas, so I think the parallel with that particular industry is maybe threefold. The first one is we are not building a brand new system. We have to live with the legacy systems. We already have nuclear plants, the same way that we already have gas pipelines, and the same way that we already have utilities grids. So it's about being able to bring the data from equipment that has been there for 30 years and trying to understand what is this equipment. Because truth be told, even if you recorded what the asset was 30 years ago when you installed it, you've probably done tens of maintenance on it, and it doesn't look like anything it used to look like, right? So that's one challenge that can be solved with data and AI, right? And it's about being able to ingest this data. It's about being able to ingest it in real time. And I like to say, like, data is needed for AI, but now we are at this pivotal point where actually AI is needed for data. We actually develop AI solutions in order to help get your data ingested and transformed to the level of quality that you can do AI on top of it, right? I think the second parallel we see in all these industries that we cover is an aging workforce and a challenge to attract talent. And therefore, while AI may be seen by some as a dangerous thing that's going to replace people, at least in the industry that I look at, it's absolutely necessary in order to cope with the increased demand in energy. And we need to augment every single person that works in this industry with the AI augmentation, right? The third point I'll make, I know nuclear safety is extremely important, and data sovereignty, privacy is also very important. But the parallel I made is with oil and gas maybe 10 years ago, right? Subsurface data, which is what are the reservoirs that the very large operator owned and what is the amount of reserves, is extremely critical and extremely private because most market capitalization are based on that, right? But that move to the cloud and to using AI and to collaborating on this data in a secured manner with clean rooms has really picked up. And today around the world, if you look at oil and gas operators, there is very few that remain on-prem, right? So I think one of the challenges we see in the nuclear space, which is to get access to this data, is one that is going to be solved by some of the solutions that we're bringing up around cybersecurity, or even with our partners like Google, right, where we are able to do POCs and these kind of things in completely gapped solutions, so you can move very fast.
Thank you, Julien. So the data barriers you're talking about can echo the construction pains, and I'm turning to you, François. What do you think would be the regulatory or the, let's say, execution hurdles you would see when bringing some digital innovation in this environment?
Well, in fact, the main challenge is, as Julien said, is workforce and the human being factor. First, it's a highly complex project, and it's a long time since we have done so many. So we lack the experience, and we don't have the old guys, the tenure guys that can help us to fix all the complexity. But B, and this is the most and the new challenge, is that when you go digital, the main limit is and the main challenge is the human factor and the behavior of all the people. As Lou said, we need cooperation. That's a new way of working. You don't have the same sequence. Everyone has to contribute positively to the design, to the digital, let's say, environment and building model of the data and the project. And this is the pain point that is the longer to fix. So that's where we have to challenge this industry that is where the value comes from the human being and the organization. The solution that digital can help us is to fix the complexities through the 3D, 4D modeling, making the model more robust and bringing everyone cooperate. So big challenge, but some ways to fix it.
So as we talk about cultural challenges, let's talk about another cultural issue with you, Jim. The cultural issue with safety authorities, because obviously we're bringing very innovative technologies in what was a long time very traditional environment. So how do you tackle this issue with safety authorities?
And that is a great question. So moving forward with AI is not about the technology. It's about allowing the flexibility for utilities to make decisions based on the information that they get from AI. It's using that. You have to have the flexibility for maintenance optimization. You have to have the flexibility to change the frequency of your surveillances that are required by tech specs. But to do that, you have to be able to message to the regulator that a safe plant is a risk-informed and flexible plant using the technology that we have available. We can make better decisions. We can make safer decisions using digital innovation as long as the regulator allows that to happen. So the message that to move forward, we have to have a cohesive and consistent message to our regulator around the world. And that the use of artificial intelligence and digital innovation to provide flexibility for maintenance optimization and decision making allows us to be a safer plant. Sometimes the safer plant is not requiring a shutdown. It's to fix an equipment issue and stay at 100% power in mode 1. But you have to have the ability to have that flexibility and be confident in the information that's provided by the innovation and the information that you have available. So I'll break this into two parts. Operations is about planning and about responding to emergent issues. The planning part is where AI can provide insight into making a better work plan. The response from an unplanned or transient, AI can help operators mitigate that transient by understanding and diagnosing the issue in the plant. So on both sides, you can plan better, you can respond better using digital information, innovation, and AI.
Thank you. So from safety, I'd like to shift to security, because talking about data, cloud, of course, we immediately think about cybersecurity. And cybersecurity in such a regulated, sensitive environment, this is clearly your field of experience, Elliot. So please tell us about it.
Yeah, so you're absolutely right. Cybersecurity is absolutely critical in any of these industries. Anytime we're doing something that's safety of life critical or mission critical, cybersecurity is absolutely key, right? And this is sometimes, when we think about it, juxtaposed with, well, we want to get access to all the data, we want to build things, right? So I like to tell folks, we should think about the data in our organization. We were talking about how much data exists in the nuclear industry. We should think about that data as potential energy. Right, and AI as the key to unlocking that potential energy, right? But in order to do that, you have to have a really clear plan. You have to have not only an overall security plan for the data, but you have to have a plan that goes down to the individual data elements, what the risk of those data elements are, what the risk of those data elements when combined could be, and how you're mitigating for it, right? So at Google, we've obviously developed a number of methodologies for cybersecurity, not just because of the immense amount of data, of course, we manage, but because of the immense amount of data we work with and with our partners in Google Cloud. specific to critical national infrastructure and nuclear energy. What we've done with Google Distributed Cloud is build a highly secure stack that is physically air-gapped from everything else so that you can effectively test and build the applications that you want and then run the cybersecurity test cases in a known environment with actual live data and get the outcomes so that you can ensure that regulators become comfortable with the applications and outcomes that you're building. And I think if you really approach it that way, right? Plan, understand risk, create an initial sort of deployment plan, POC in a controllable environment, and then present to regulators, you've set yourself up for success. Where you will not set yourself up for success is just going in sort of, well, let's see what happens. It's rarely a good plan.
Well, Lou, I have quite a difficult question for you because we heard about the regulatory safety challenge, about the cultural challenge, about the cybersecurity one, data strategy. So which one is your favorite or your priority challenge?
Cecile, it's all of the above. Unfortunately, in the business we are, it's all of the above. They are equal to us. And that's why we are open, working in an open ecosystem to work with it. On the regulatory framework, for instance, what our strategy is, and I always reinforced it very, very strongly with our teams, we cannot develop something and then go to see the regulator. We need to include the regulator from the very, very beginning so we understand what are the constraints, what they feel comfortable doing with us or not. And by the way, one of the activities where we do and we see much of value on AI is actually improving the process on licensing with the regulator. But we include them from the very beginning. You know the framework where you can play. That creates a lot of security. Second topic about cybersecurity. One of the reasons why in Westinghouse we are presented in the full stack of AI internally is because you need to have that kind of competencies that obviously is a team effort. It's a team effort between innovation teams, IT teams, compliance teams, regulatory experts that help us to do it so we can communicate with tech colleagues in how to do it. When we start launching and people realize that actually we're pretty advanced, first we use it for our users, and our customers say, that is very interesting, we would like to have Bertha, we like to have access to what you have. Well, the problems started. How the interoperability of those systems, what is the cybersecurity? How our IT colleagues, they were like, no way we're going to open our systems to anybody else to have access to what we have learned. But discussing with Databricks, and specifically in this case with Google, as Elliot was positioned, they have a system where actually you can have a hybrid system. Not everything needs to be cloud, not everything needs to be primes. You can be kind of the mix. Well, we call it Bertha in a box. Basically, it's a deported cloud that can go up to 80 teras that allows you already to do a lot of the things we can do in a fully protected environment. So those are the things that we are exploring now. It's not something that is going to happen in 10 years to now. We are currently trying to see how we can develop it in our environment so we can use it with our customers. So you see, it's really all that actually makes the difference. And without the cybersecurity piece, without having experts that they are all the time engaging in what are the bricks that are going to make us able to operate, we cannot use it in nuclear. It's just how it is. So we take it as a constraint from the very beginning of the project.
Okay, thank you. So now, let's move forward. Let's say that we're in 2027, in 2 years' time from now, next WNE. We're around that table. So what will we be talking about when talking about this wonderful match between digital and nuclear? Another way to ask you how we can expect those technologies to accelerate nuclear projects. Because what we see all around the world is a political acceleration, customer acceleration, a demand for reliable, abundant, carbon-free energy, nuclear. So first question to you, Jim. As you are running a fleet of the largest nuclear fleet, you're providing, I think, 10% of the low-carbon electricity in the US. You have customers who demand a lot of energy in the digital sector. So you have to answer this. So how do you see the role of AI and of all those technologies in, well, really dealing with this risk of delays, schedule delays, overruns in the projects?
Well,
easy question.
Easy question, yeah. I hope 2 years from now, we're talking about construction projects. We're talking about restarted plants that have been shut down for economic issues. And the way to get there is to have a consistent technology. It's working together. And it's not a one solution. So if you look at Constellation is very aggressive in AI. And they see the benefit in reducing O&M costs for the existing fleet. But I think that can translate to the construction as well. But I think all of us, in terms of the industry groups, owners group being one, IMPO, WANO, NEI, all of these industry groups and EPRI working together can provide a cohesive tool for digital innovation that allows us to move forward consistently and with confidence. So some of the examples that I would say, monitoring equipment performance. We've got an advanced algorithm that we're working on now that will monitor instrumentation to see if there's a deviation to make better decisions on maintaining it and surveilling it. We've got an AI pilot that's happening in Constellation on work planning to take the entire E-week process up to execution and collapse it so that to remove some of the intensive resources necessary. So we're going to see efficiencies gained. We're going to see the payoff, the benefits in safety and efficiency and work planning and construction. And I think that is the conversation we're going to be having in 2 years.
Same question for you, Elliot, because you are, I would say, in the middle of the reactor, the digital reactor. So how do you see the role of AI to really propel this wide shift?
Yeah. So if we go back to that metaphor of data in the organization representing potential energy and AI being a mechanism to unlock it, what is it really unlocking? It's unlocking organizational agility, right? When you take a huge amount of data in an organization, you take it for safety monitoring, you take it for construction, you take it for maintenance, you take it for even staffing, things like that. What you're really doing is creating organizational agility, right? So one of the things I've been most impressed with that AI can do is actually in that construction field, is figuring out, in a traditional construction project, we sort of have a list of tasks that have to be completed and an order that they have to be completed in. But it turns out that if you gather enough data across enough instances of construction, we were talking about this earlier with the welding, if you gather enough information, you can actually figure out which of those steps are actually critical path to each other, which ones can be accelerated, where you can pre-position things. What it really does is lets a whole organization that previously had been doing things partially because, quote, that's the way we always did it, right? And partially because there's no immediately intuitive alternative. What it really lets you do is start exploring alternatives that humans might not have quickly identified themselves. And it also lets you unlock some of the sort of unwritten tips and tricks that people have been using, but may not have sort of officially documented. And so really, AI is creating agility out of data.
Agility is such a word we were not used to hear when speaking about nuclear, but it brings me, Julien, to what you previously said, that there were some cultural challenges, and this may be the most difficult ones to deal with. So for you, how fast will it go?
Well, it can go very fast. But I guess to the praise of Lou and Jim, companies like Westinghouse and Constellation move fast because the leadership has understood that you need to move fast, and that's what leaders need to do. They need to educate themselves on the art of the possible today. If you do that, you move extremely fast. So I'm not going to share a use case from the nuclear because I leave Lou and Jim share that, what we do with them if they want. But look, today we have utilities companies that are able to look at weather forecasts 5 days ahead. They are able to know 90% accuracy, what equipment's going to fail and when. They are able to dispatch their crew in advance before the trees fall and the snow falls. They are able to look at their HR data and know who are the right competent, certified people that are close to the right area to be ready to go and do these repairs. They are able to inform their customers about how long it will take to fix these repairs. All of this is happening today, right? And there is no reason why the nuclear industry cannot move faster. And by the way, we have to move faster because there is competition. I'm a firm believer, and I say it in all my speech, it's not about is it either nuclear or solar or wind, it's about all of them because the world needs a lot more energy. But we are competing with a solar plant would take 2 to 3 years to be put from permitting to the first electron coming out. The nuclear industry needs to move towards that, right? If it keeps on taking 10 and so years, it's not possible. So we can move very fast. We must move very fast.
Yeah, thank you, Julien, for reminding us about the very competitive energy environment we're living in. So Julien with Databricks is fueling the data revolution. So are you fueling the construction revolution, François, at P-Batrignol with digital technologies?
Yes, for sure. Jim and Elliot explained it, how we can leverage data and AI in decision making. But so to say, to formulate it some kind of paradox, we need to start not slowly, but step by step to go faster. This is what an AI enables, is you test all the design phase with this digital modeling that can, and you talked about tips and intuitive, and then you move to analytical with very, very, very complex project interaction, and you make it more reliable. And so to put it in a nutshell, within 2 or 3 years, we can expect to be ready to be faster for the second, third, fourth, 10th new nuclear plant, because you have the learning curve, and you will be back-tested because we lack of very old data for the very first shift of and wave of construction. And so to quickly answer to your question, in 2027, we will be ready to be more reliable, faster, but we need to do it step by step. So start slowly to accelerate then. To bring cost certainty, delivery on time, so all the, let's say, the pain points of the construction industry that we have to deal with, and then we are well known, and we can hope within few years, given the impact of the nuclear industry and the need for the renewal of nuclear industry, we will fix them. So provided that we get enough energy to fuel the AI, we need to nurture the AI with energy. So I'm very confident that we will overcome all this challenge through data and AI, leveraging the data that we will all together gather in a safety manner, because we have a lot of threats. And we have also some kind of enemies that will be very interested in putting these threats. So ready to go faster.
Okay, let's go faster, but be patient, if I understand well, at the beginning. So, Lou, what a challenge. So about this time acceleration, well, you know something about it after the big announcement of last week. So how do you see yourself, your company in 2 years with working with those technologies?
So it's a great transition for what Francois was saying. Usually in the US, we use this expression, what energy and nuclear can do for AI and what AI can do for nuclear. So in the next 2 to 3 or 5 years, what I'm seeing is a very large innovation ecosystem that is going to help to deploy all those reactors that we need. So today we are already exploring, and we are actually having already tools that allow us to de-risk the construction phase on the nuclear piece. And I think that ecosystem is shifting tremendously. If you see probably 5 years ago, I'm sure we will not have been this round table with Google Cloud and with Databricks. So that gives me a very positive view. Obviously, I work in innovation. I need to see it bright because we need to make the impossible. And I think these tools with the human power that is going behind. And I agree, I think you have heard the human piece of it for all of us is not possible. So pretty bright, thanks to this tool, but also thanks to the manpower and the human part of it that is making it possible.
Well, thank you so much. So we're reaching the end of our session, and I would like to sum it up with 3 words. Now you will tell me if you agree, and maybe you would like to add one. So I heard 3 A's. The first A is about alignment, because basically what we have done today is aligning, and what you're doing every day is aligning the view of different players of the sector, including hyperscalers, data scientists, people we would never see around such a table 2 years ago, as you rightly say. So alignment. Second, agility, so completely new. And thanks to the data digital guy, we are bringing agility in this sector. And third, acceleration. And what is striking from your answers, each from your field of expertise, each from your window, you all see an acceleration in this sector. So thank you very much for sharing it with us. And last message, so it is happening. We're not talking once again about the future. And if you want, after hearing about AI, about technology, if you want to see them, there are wonderful demos in the booth. So the booth of Westinghouse, which is the F104, there is an AI demo you can all go and see. And on the booth of SPI Batignolles, A17, if I'm not wrong.
Yes, next to the startup village.
Next to the startup village.
Another construction phase.
Well, the new SPI Batignolles in the startup village. Please go and visit. It's absolutely fascinating. But before, please applaud our fantastic panel, whom I thank very, very heartfully for their presence and for sharing all those bright ideas. Thank you very much.
Thank you.
Thank you, Cécile.
So if you're the first one,